Hi, welcome to the fourth period LLO group with me. Today we'll be studying rational functions. A rational function is the quotient of two polynomials. Our first example is f of x equals x squared minus 4 divided by x squared minus 6x plus 8. It may or may not be continuous. When you graph the function, you'll see that this continuity occurs at 4 and 2. Now to actually solve the equation, here's Danya.
Hi, we're going to solve this equation by first putting the denominator equal to 0. X squared minus 6x plus 8 equals 0. Then we're going to factor it, and I'm sure you all remember how to factor.
Yes.
Okay, so let's factor them. First, we're going to write again the equation. And then we're going to factor them when we switch to another marker. Okay, so x minus 4 is 1, and x minus 2 is the other one. And then we're going to set them equal to 0 so we can do it right. Okay, and the actual one is x equals 4 and x equals 2. So now, each factor, we're going to plug it into the x, okay? So at the end of plugging the 4 to the x, it is 12 over 0, which is undefined. Which means, come on, you know it.
I know it.
A vertical asymptote. Okay, and for the other one, when you plug the 2 to the x, it is 0, 0. Which not a lot of people know this, but it actually is an indeterminate.
Indeterminate?
Which means we have a hole in our graph and equation. So that's one example.
Thank you, Danya. Now for our next example, my friend Robert will be demonstrating it.
Here, our next example will be fx x cubed plus 1 over x squared minus 1. This will show when degree of the numerator is larger than degree of the denominator. When the degree of the numerator is larger than the degree of the denominator, for example, x cubed plus 1 over x squared minus 1, you can tell there will be no horizontal isotope. Excuse me. That means the numerator will be larger than the denominator.
Thank you, Robert. And that concludes our topic on rational functions today.